right, we have these three tools in our toolbox that we can use whenever we want. Good old stress is force over area. Strain is deformation over length. Modulus of elasticity is stress over strain. And last time we smushed those all together and came up with our good old shortcut. Deformation equals play. And this can come in handy, and I think we can use it in these quiz questions. Question 6 in the quiz, and by the way, the first 4 questions are more general questions, and hopefully you used the previous lecture to answer those questions. So now we move on to question 6, which is actual math, where it says find the area. And it's a steel rod that has a diameter of 1.5. What is the area? Question. If the area of a circle is pi r squared, could you just plug 1.5 into this equation? I hope you're thinking, no, I can't, because if it has a diameter of 1.5, that's not the radius. If it has a diameter of 1.5 all the way across the circle, how do we find what the radius is? Ha! What is half of 1.5? 1.5 divided by 2. I hope you come out with 3/4. Of course, if you'd rather, you can use this version of the area equation. Area equals pi d squared over 4. So you'll find the area. Then you'll go on to this next question. Here's a balcony. A steel rod is supporting the balcony, and the steel rod is 25 feet long. That rod has a diameter of 1.5 inches, or an area of 1.767 square inches. The load from the balcony is 29,000 pounds. The modulus of elasticity of this mild steel is 29 million psi. The question is, approximately how much does the rod stretch? In other words, you are looking for deformation. So, what are you trying to find? You're trying to find deformation. What are you given? Well, let's see. Balcony 25 feet long, so that's the length. Rod has an area of 1.767 square inches. The load, that's the force, isn't it? 29,000 pounds. And modulus of elasticity is 29 million psi. So what equation would you want to use? Well, how about our good old shortcut? Play. Deformation equals play. One thing you want to watch out for, though, is think about the units. The area is in square inches. The modulus is in pounds per square inches. The length of the rod is in feet, 25 feet. What do you want to do to change 25 feet to inches so that you can put however many inches long it is into this equation? Let me know if you have trouble with that. Hopefully you know how to turn feet into inches. All right, then on the next question, we have a surveyor's tape. It's a 100-foot tape, and it's, made of thin metal, so its area is actually 6/1000ths of a square inch. And this is a surveyor's tape, so we have to be exact, and we can't just flop it down over the bumpy ground. To get a good measurement, we need to stretch this tape. and we put 16 pounds of pull on this tape when we're using it, and we know that the modulus of elasticity of this particular steel is 30 million psi. Question is, how much does the tape stretch? In other words, what is the deformation? So what are we trying to find? How much does it stretch? We're trying to find the deformation. What are we given? Surveyor's tape is 100 feet long. There we go. There's the length. It has an area of 6/1000ths of a square inch. We're going to pull on it with 16 pounds of pull. We've got a modulus of elasticity of 30 million psi. What equation should we use if we're looking for deformation? Ha 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 ha, good old shortcut, deformation equals play. But once again, a word of caution. Square inches, square inches. The original length was given in feet. We want to convert this length to inches. How many inches is 100 feet? That's what you'll want to plug into this play formula. How many inches? All right. And finally, surveyor's tape in the previous question. Approximately what is the stress in the tape caused by the pull? So what are we trying to find? We're trying to find stress, good old stress. What are we given? Well, we're given the length. Do we need that? I'm going to say no. What else do we know? We've got an area of 6/1000ths of a square inch, and we're going to pull with 16 pounds of force. We're trying to find stress. What is our stress equation? Stress equals force over area. Do we have force? Yes, 16 pounds. Do we have area? Yes, 6/1000. Do we need length? No, we don't. So stress equals force over area, our good old formula. Off we go.